Hi everybody, and welcome to exercise 2 on page 63 of the workbook. And this is another exercise of using slope fields just to gain information about a differential equation. So let's read this situation together here. So wildlife biologists are studying the fish population of a lake in which a specific amount of fishing takes place. And they discover that the fish population can be modeled by this differential equation. Notice the units of p. We're talking about p as being measured in thousands of fish, okay, and time is being measured in years. So we might go over to our picture here and just mark in those units so that we're clear on those. Okay. And the picture that we're given to the right is a slope field, okay, which again just gives us information about how the population is changing, how fast it's changing and in which direction. Okay, and part A of this would like us to draw in some solution curves corresponding to initial conditions. Let's do those one at a time. Okay, and then they also want us to give kind of a description of the behavior. What are these curves telling us? So starting with p of 0 equals 25. Okay, so that's telling us that at time of 0, the fish population is 2.5 thousand. Okay, let's find that point, 0 and 2.5. That's sitting right about here. Okay, and if we do our best to follow the lines in our slope field and draw in our curve, let's see, we're going to start with a positive slope. Okay, the steepness is going to increase for a while, and then as we get over here, looks like the slope is decreasing. Okay, so we're getting a population curve that kind of looks like that. And then they'd like a description of that. Okay, so that curve that we just drew, how would you describe the way that the population is behaving in that case? Well, one thing we could say is that the population is getting bigger. Okay, and then maybe another thing is, does the population get bigger and bigger and bigger, or does it look like it's leveling off? Okay, notice that the end of the curve kind of shallows off, and at 6,000 we've got a horizontal line, so we're not going to be able to surpass that population. So in words we might say something like this. Okay, so increases and approaches 6,000 fish, assuming a starting population of 2,500. Okay, that sounds a little bit clumsy. Let me say that a little bit differently. If we start with 2,500 fish. Okay, so starting population of 2,500 fish leads to an increase in population and ultimately kind of an approach to an overall population of 6,000 fish. We're getting that information from the curve that we drew. Okay, well, what about the second one then? P of 0 equals 8 is saying what would happen if we started with 8,000 fish? Well, we're going to be up here. And notice that in that part of our slope field, the slopes are negative. And so our fish population is actually going to decrease if we start there. Okay, I'm just doing my best to follow the arrows here. Okay, this is not an exact science, but very roughly speaking, we would get a curve that maybe looks like that. Okay, so how would we describe what's going on there? Okay, well, if we start with 8,000 fish, we can see that the population decreases. Okay, that curve that we just drew is going down. And what do you think about approaching behavior? Does it look like we're approaching anything? Kind of looks to me like we're approaching that same horizontal line of 6,000 fish. Okay, so I'm going to add that. The population decreases. Okay, and approaches 6,000 fish. Okay, so you can maybe think of it this way for statement number 2. 8,000 is maybe too big of a population for our lake. It can't support 8,000 fish, and so the population will start to decrease and sort of level off at 6,000 fish. Okay, so I think we've answered part A. Let's move on to part B. This is kind of an interesting question. Are there any scenarios in which the entire fish population of the lake dies off? Okay, so it's kind of like asking you, do you see any possible starting populations for the amount of fish in the lake where if you started with that population, eventually you would wind up with 0 fish? Okay, well, if you study this slope field a little bit, you'd be looking for a situation where the slopes are negative and your curve goes all the way down to a population of 0, which would be down here. Okay, if you look at that, one example of where that would happen would be maybe like if you start with 1.5 thousand fish, because notice that if you draw the curve there, its slope is negative and it's getting more and more negative, and so you're going to smack into a population of 0 right there. Okay, now I used a starting population of 1.5 thousand. Are there other populations, starting populations, where that would happen? Notice that any starting population between 0 and 2 is going to kind of follow the same pattern that we have there. Okay, so let's answer the question this way. Okay, if the fish population starts below 2,000 fish, okay, we see from the slope field that the population will decrease to 0. Okay, and that's what we mean by a die-off. Okay, we have a certain amount of fish and we wind up having 0 fish at the end. Okay, and maybe just for the sake of your notes, see curve 3. Okay, and when I say 3, I'm meaning the third curve that we drew up there. Okay, and I think we've answered all the questions they wanted us to.